So here in the earlier lecture I talked about law of conservation of linear momentum. Now I will talk about law of conservation of energy under Galilean transformation. So what is the meaning of law of conservation of energy, as I did in the earlier diagram? So in the similar fashion, say half m1 v1 square is the kinetic energy of the first particle, sorry, m1 before collision, say it is the kinetic energy, and it is the kinetic energy of the particle, second particle, and their sum is equal to the sum of kinetic energies after collisions. So m2 v1 square plus half, oh sorry, yeah, m1 v1 square plus half m2 v2 square. Say this is for the S frame. Diagram will means the same, but now I am talking about the energy, and earlier I talked about the momentum. So similarly, in S prime frame, what will happen? In the S prime frame, it is this one, m1 u1 prime square plus half m2 u2 square. Its prime frame is equal to, yeah, it is m1 prime v1 prime square plus half m2 prime v2 prime square. So what will happen, as mass is an invariant quantity, so that means m1 prime is equal to m1, m2 prime is equal to m2. Similarly, using this relation, this equation can become, it is half m1 u1 square plus half m2 u2 prime square, so prime should be there, is equal to half m1 prime, sorry, not prime, but it is m1 v1 prime square plus half m2 and v2 prime square. So what should I do? It is half m1, and this u can be written as, say, u minus v, so it is u minus v and whole square, because u vector is equal to u minus v, and if I take it square, then u square, sorry, u prime square can be written as u vector mod square is equal to u minus v whole square. It can be written like this. So it is m2, it is, oh, u1 should be here, and it is u2 minus v is equal to 1 by 2 m1 v1 minus v. It is like this, and whole square plus half m2, it is v2 minus v, that's whole square. I have to start from here, and I have to be here. I am using certain v because I have to try to remove the summation, sorry, prime, not summation. So by starting with this, I will try to reach at this particular point. Let us see whether I will reach or not. If I reach, then I can say that it is invariant under Galilean transformation. Otherwise, it is not invariant under Galilean transformation. So let us proceed as follows. So it is 1 by 2. So it will become m1 u1 square plus half m1 v square. It is m1 v square minus half 2 m1 u1 v. I am basically expanding this particular expression, plus 1 by 2 m2 u2 square plus half m2 v square minus 1 by 2 into 2 m2 u2 into v. This is it, and this is further equal to 1 by 2. I just expanding now this one and multiplying with m1, so it is 1 by 2 m1 v1 square plus 1 by 2 m1 v square minus 1 by 2 into 2 m1 v1 into v, plus similarly by expanding this, what I am getting? I am getting m2 v2 square plus 1 by 2 m2 v square minus 1 by 2 into 2 m2 v2 into v. This is it. So if I try to look at this, this is half m1 v1 square, and similarly it is half m2 v square, and on the other hand similar type of terms are there with me, so both are equal and opposite, so these will cancel out and this will cancel out with this. So we will remain with the 1 by 2 m1 u1 square and plus 1 by 2 m2 u2 square, and let us try to look at this will cancel out with it and this 2 will cancel out with it. So it is what? It is plus or the minus? It's minus, yeah. It is m1 u1 plus m2 u2, and both are having v, so v can be taken outside. So this is equal to 1 by 2 m1 1 by 2 m1 yeah, it is m1 v1 square, this term and then this term, plus 1 by 2 m2 v2 square. Then let us have it, this will cancel out with it, so these two will cancel out, so it will be, so minus can be taken outside because it is minus, it is minus, so inside it will be m1 v1 plus m2 v2 multiplied by v. So these two terms, as if I apply the law of conservation of linear momentum, then m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. So if I use this particular relationship here, the law of conservation of linear momentum, then what will happen? These two terms will cancel out because both are equal and opposite and lying on the opposite sides of the equality. So that means this whole of the term will cancel out with this, so because both are equal in magnitude. So what we are getting, so half m1 u1 square plus half m2 u2 square is equal to half m1 v1 square plus half m2 v2 square. So thus I have started with this particular relation from here. I started from here and I reached at this point. So what does it mean? It means that the law of conservation of energy is the invariant under Galilean transformation. Law of conservation of energy invariant under Galilean transformation. Here I am using only kinetic energy, and in some text people are also using the kinetic plus the potential energy. That can also be shown that is also invariant under Galilean transformation. So that's all for this lecture.